Hi everybody, Ms. Mokano here, and today I wanted to go over this worksheet that you guys are doing in class on power and electrical energy. So let's start with power, okay? So power, as is given to you right here in the background information, power is how fast energy is being converted from one form to another. And since we're talking about electricity in our current units, the formula for power that is applicable to us is given to us right here. Power is current times voltage. Okay, so make sure you understand this formula. It's giving you all the information you need right here. So power is abbreviated as P. Current, as we know from our previous studies, current is abbreviated as I, capital I. Voltage is abbreviated as capital V. So here's your formula for power. Power is I times V, current times voltage. The units for all these quantities are given to you in this table. So voltage, as we know, is measured in the unit of volts. Current is measured in amperes, and power has a unit called watts, which is abbreviated as capital W. As in the past, I'm also giving you the triangle. So however you are comfortable, you can use the triangle if that helps you with your formula. So P for power equals I times V. Or you can use these various forms of the formula that are given. All right, so let's solve some of these problems together and see how we apply that formula. So let's solve these ones right here and use our information that we have. So problem number 1 is giving us current of 2 amperes. So I equals 2 amperes. That's the current. V, the voltage, is 12 volts, and it's asking us to calculate power. Using either the triangle, if you're comfortable with that, or the formulas right here, we can see that we can easily solve this problem by just applying the formula for power equals I times V. Current is given to us as 2 amperes times the voltage, which is given to us as 12 volts. Plug that in the calculator. 2 times 12 is 24. And my final thing is, what is the unit that I have for power? Well, the unit for power, if I forget, I can always check my little table right here, is watts, capital W. Okay? So that's how you would do that problem. Let's do problem number 2. In this case, we are given the voltage V, 120 volts. We are given the power as 1,000 watts. We are asked for current. Well, I can go up here and use my triangle. If I use my triangle, I would cover up the current, and I would see that the formula for current is just P divided by V. Cover up the current. P is on top, V is on the bottom. That's my formula. Or I can use the formula straight from here, okay? Now let's plug in the values. So P is given to us in the problem as 120 volts. I'm sorry, that was actually V, so let's erase that because that is incorrect. Let's plug in the correct numbers. So P, the power, is given to us as 1,000 watts, divided by voltage, given to us as 120 volts. If you plug that in your calculator, I believe you will get 8.33. And what is the unit? Don't forget your units, okay? So we're dealing with current. That's what we just calculated. Current is in amperes. So capital A is my unit for current, amperes. Moving on to number 4. We are given current in this case. We are given voltage. We are asked for power. So let's calculate the power again using our formula for power from above. We can see that power is, if we look right here, we can find the formula for power, and it's just current times voltage, so I times V. Okay. In this case, current is given to us as 10 amps. Voltage is given to us as 240 volts. So I do that multiplication, and I get 2,400. All right, what is my unit here? Be very careful with the units, okay? So for this formula, the unit of power is in watts. So here's my unit in watts for power. However, you can see right here, the problem is asking you to provide your answer in kilowatts, not in watts. So how do you do that? Let's go back to our King Henry. Died by drinking chocolate milk. Remember our unit conversions from unit 1. K was for kilo. B was for base, right? Remember that, kilo. Then we had hecta, deca, base unit right here, deci, centi, and milli. If you don't remember this, please go back to unit 1 and review this. In this particular situation, we are working with a base unit of watts. All right, that is our base unit that we're working with for power. And we want to convert from watts to kilowatts. We want to go from watts to kilowatts. So what do we have to do? Well, if I want to go from watts to kilowatts, I got to take my decimal point right here, which is at the end, and I'm going to jump 1, 2, 3 spots to go from base to kilo, okay? So if I take my decimal point and I move it by 3 to the left, 1, 2, 3, I am going to end up with an answer of 2.4 kilowatts. And now my problem is all set. Finally, let's solve for V over here in number 5. So I am given my kilowatts right here. I know that in order to use this formula, I gotta have my power in watts, okay? So I gotta take this and convert from kilowatts to watts. So let me see what that conversion is gonna look like. Again, I'm gonna go and use my King Henry died by drinking chocolate milk. I'm gonna use my conversion factor. Well, in this case, I am starting with kilowatts and I wanna convert to watts. So I am starting at kilo. And I want to go to my base unit, which is watts. So I'm going to go 1, 2, 3 jumps to the right. I'm going to take that decimal point. I'm going to do the same thing here. I'm going to go 1, 2, 3 jumps to the right. I'm going to fill any empty space with zeros. And that will give me 20 watts is my conversion from kilowatts to watts. Now that I have my power, I'm in good shape. I can go ahead and calculate my voltage using my formula from here or using my triangle, whichever one is easier for me. So voltage is simply power divided by current. My power in watts is 20 watts divided by my current, which is given to me as 0.5 amperes. 20 divided by 0.5 is going to be 40 volts. All right, so that's how you solve these kind of problems. Let's move on to part 2, in which in your assignment, in which you are given word problems, and let's see how we would solve those. So in this situation, it's a little bit trickier because now you have to identify what is what. So the prompt 7 is telling us what is the power when a voltage of 120 volts drives a 2 amp current through a device. All right, so what is the problem giving me? Well, it's giving me this number. What is that? It's a voltage. So I'm going to put it under V for voltage. So I know my voltage is 120 volts. What else is the problem telling me? It's telling me I got a current of 2 amperes. I'm going to put that under my current. So 2 amperes goes under current I. And then I simply, just like we did before, I'm going to use my formula right here to figure out the power. So the formula for power, I can select this one, or I can use my triangle, whichever is easier for me. So power is just simply current times voltage. Current times voltage. Current in this case is 2 amperes. Voltage in this case is 120 volts. 2 times 120 is going to give me 240. And my unit is watts, because I just calculated power. Let's talk about number 11 down here. Let's see how we would solve that. Let me just move that up a little bit. There we go. All right, let's talk about number 11. So in number 11, let's see what information we are given. What information are we asked to find? So the problem right off the bat says, what is the current? The current is what they want me to find. When a 0.06 kilowatt lamp, so what is this 0.06 kilowatt? That is power. How do I know that? Because kilowatts and watts are units of power. Okay, so that is giving me the power. So 0.06 kilowatt lamp, that's the power, is connected to 120 volts. What is 120 volts? Well, that must be a voltage. And how do I know that? Is because volts are a unit of voltage. Right here, volts are the unit for voltage, okay? So the voltage is 120 volts. All right, so how do I calculate that current? Well, I can go back to my trusty formulas over here, either my triangle or my formulas, and the formula for current is simply power over voltage. So can I go ahead and take this number and just plug it in for power and divide by voltage? Can I just say, oh, okay, so it's 0.06 divided by 120? No, that would not be correct. Why not? Because this right here is kilowatts. Remember, in order to use this formula, and if I want to get my current in amperes, I gotta have my power in watts, like it says here. So I can't just straight up use this number. First, I gotta convert it from kilowatts to watts. How do I do that? I use my King Henry Diet conversion scale, just like we did before. I'm going from kilowatts to watts. I'm gonna have to jump to the right 3 spaces, and basically that will be equivalent to 60 watts. Now I can take my watts, my 60 watts, plug them in the formula where the power goes, and my answer for this is going to be 0.5 amperes, 0.5 amps. All right, I will make another video where we're going to discuss electrical energy, which is a little bit more challenging. What I would say for this, so for this part of the worksheet where you're dealing with power, make sure you convert your units, okay? So paying attention to units is very, very important. Make sure that whenever you use these formulas, your power has to be in watts. So if you're given power in kilowatts, like we were in this problem, or in this problem down here, make sure you convert that from kilowatts to watts, or vice versa. You may be asked the opposite, like you were in this problem. We calculated our power in watts, but we were asked to provide the answer in kilowatts. So whichever way you go, make sure you pay attention to your formulas. And I will see you guys in the next video where we're going to go over electrical energy.